Of equations by elimination homework. Let's go ahead and get started with problem number 1 here. So I'm looking for a combination of an x and a y value that's going to make that first or both of these equations true at the same time. In order to find this, I'm going to use an algebraic method called elimination, and elimination relies on the fact that when I add both of the equations together, I can do it in a way that eliminates one of the variables. So what I'm looking for is something called a zero pair, where two variables have the same, or two terms have the same variable but opposite coefficients. We see in problem number 1 that's the case with x, because we have a positive x and a negative x. And once that's the case, I can just add these two equations together, left to left, right to right, combining the like terms as I go, and come up with a new equation that has that zero pair eliminated. So if I add these together, that x and that negative x are going to cancel each other out. The negative 4y and the negative 6y will combine to be a negative 10y, and the negative 8 and the negative 2 will combine to be a negative 10. So both of these equations were balanced, so adding them together should not make them unbalanced. But when we add it together, we have an equation with only one variable, and if you have one equation with one variable, you can solve for that variable. This negative 10 is multiplying the y, so I'm going to divide both sides by negative 10, and I get that y equals 1. All right, but I'm not done solving this. I need to still find an x value. I wanted a combination of an x and a y value, so I plug this value back into this y here. So this top equation becomes x minus 4 times y, but y has been replaced with a 1, equals negative 8. Now I've got a new equation that has only one variable, and I can solve for that variable. X minus 4 equals negative 8. Add 4 to both sides. We get x equals negative 4. Put this together into an ordered pair, x comma y. It's going to become negative 4 comma 1. All right, and that's the answer that I want to box. Let's see if we can do the same thing with problem number 2. It's a negative 5x and a negative 5x, so that's not a zero pair, but the y actually does form a zero pair, positive y and negative y. So again, if I add these two together, those y's are going to eliminate. Negative 5x plus a negative 5x becomes a negative 10x. These y's eliminate, and 25 plus 15 is 40. Get rid of that negative 10 by dividing both sides by negative 10. We get x equals negative 4. Take this answer, plug it back in for this x right here. Negative 5 times x, but x has been replaced with negative 4, plus y, so that y is back. It only eliminated when we combine them, but we're just focusing on that top equation now. Equals 25. Complete the multiplication here. 20 plus y equals 25. Take away 20 from both sides, and I get y equals 5. So x comma y becomes negative 4 comma 5. That's the answer we want to box. Okay, I say I've got a zero pair in 3 and 4, so this technique should work there. Same with 5 and 6. But actually, I want to do problem number 4 just to show what can happen sometimes when we're solving these. So I'm adding these both together because I see that I have a zero pair. 4y plus a negative 2y becomes 2y. Negative 20 plus 18 becomes a negative 2. Divide both sides by 2. We get y equals negative 1. Okay, I thought this was going to be a weird one, but this is just actually a normal one. I'll finish it just for good practice. 2x minus 4 equals negative 20. Add 4, 2x equals negative 16, divide by 2, divide by 2. X equals negative 8, so negative 8 comma negative 1. Better not cross on that problem. Box my answer. Let's see, I know there's ones on here that have interesting solutions. Oh yeah, so 3 is a no solution if we look at the answer key. Let's go solve that one and see what that is. And 6 is infinite number of solutions. So let's solve 3. 3 is a case that's got an interesting result. So I've got a zero pair, but I've actually got two zero pairs. So let's see what happens when I add them together. these cancel out and these cancel out. I have to write something on this side, so I write a 0 equals 20 plus negative 30 is a negative 10. This is a false statement. And whenever we reach a false statement by legal algebraic moves, it must mean that the original system has no solution. All right, so you can remember that now. If you ever get a false statement while doing elimination, you can write no solution and box that as your answer. Which one did we say had infinite? Number 6. Let's see why number 6 has infinite solutions. Okay, so I've got a 0 pair and a 0 pair. So it means I'm allowed to add them together, but that both of our terms will cancel. This is the same setup for no solution. But on the other side, our constants are also a 0 pair. So we get 0 equals 0, a true statement. And if we get a true statement, it means we can't ever come up with a combination that works for one that won't work for the other. And this means there are infinite solutions because there's going to be infinite points in that line. It's like 2 lines overlapping. All right, we can box that for number 6. Number 7, we see we don't have a 0 pair, but we can easily form one because we have an identical pair with these negative 6y's. So take the top equation and multiply it by just negative 1, meaning we're multiplying both sides by negative 1. This is still a balanced step. And we get negative 5x plus 6y equals negative 9. Copy down this equation below it. X minus 6y equals negative 27. Add them together. Combining like terms as we go. And we'll see that the y's do eliminate. And we'll finish this problem up for you guys, but you should be able to do this one on your own by now. Negative plus a negative, still negative there. Very careful with positive and negatives in these types of problems. X equals positive 9, that's just half of our answer. Got to go plug it back in. We'll plug it in right here. 9 minus 6y equals negative 27. Take away the 9 from both sides. Negative 6y equals negative 36. Y equals 6. And we get 9 comma 6 is our x comma y, and that's the answer that we box. Okay, that's that for this video. Have a good rest of your day.